one.
All right, so for our group project, we're doing a Tron game on our CPU. And yeah, so it's just a 2-player Tron game. It looks pretty similar to that, or it should. The input is through a PS2 keyboard, and the output is onto a screen over a VGA cable.
Awesome. So, of course, we had to implement a CPU. It's a 16-bit CPU and ALU with memory. What's kind of cool about our CPU is that it runs most instructions in 2 cycles with load and store, being 3 cycle instructions. And our CPU also specifically implements write shifts. And then also, because we needed to be able to perform a jump table, it also is able to branch with an offset from a register, as well as a special instruction to load from a peripheral register. And of course, we built an assembler to compile the required assembly. In order to run all of this, though, we needed some software. And the main element of this software is a matrix which tracks the historical position of the entire object of the entire space. So every single block of the screen is mapped to this array, which has about 2,000 positions in it. Each position, no, it has 20,000 positions in it. So each of these positions contains either a 0, nobody's been there, or a player number for specific players who have been there. And using this, the VGA can draw the game screen, but then we can use it to update where players have been. So besides some setup code, the main bulk of the program checks the current state of what the keyboard input is and updates the direction that the person should be going in, updates the player's position, and then gets the cell from that matrix and puts it into and checks whether it's clear. If it's not clear, then that ends the game, or it will write the player's ID into the cell. And it does that for both players to be able to perform the necessary calculations. We did a lot of testing of this software in ModelSim, and we can confidently say that the software is working as intending. So it properly accepts the direction input, writes the matrix, and ends the game at the proper times.
So as we have mentioned, our input to the game is done using a keyboard through the PS2 port. The way this works is it'll keep track of which keys are pressed down of the keys that we are listening to. When a key is pressed down, it sends a make code to the keyboard, and when it's released, it sends a break code. And we can use these to keep track of which of the keys are pressed down. Specifically, the keys we are listening to are A, S, W, and D to control the player 1 movement, and the arrow keys to control the player 2 movement. And then when the game has stopped and ended, the spacebar key starts a new game. So these are all the keys we are listening to, and we keep track of them in a register. And then when the special instruction we implemented, the LD key, load key, you supply it with a different register that then loads it into the CPU, and you can use it from there.
So our VGA is composed of a controller, an address generator, and a bit generator. And the controller uses board clock and various other constants that are determined by the board to determine necessary values for drawing to the screen, such as H count, which determines the X position that's currently being drawn. V count determines the Y position. H sync, V sync, and bright are all used to help determine when to draw to the screen. And then our address generator checks a specific memory address for a flag that contains a value saying which screen we need to draw. So 00, draw the game screen. 01, draw player 1 win screen. 10, play player 2 win screen. And it also creates and outputs an address to pull from memory based off of what the flag brought back. Then our bit generator takes in the data that was retrieved from memory by the address generator. It's synchronized with H count and V count to determine where to draw on the screen. And it accepts a 16-bit word from memory and breaks it into 8 2-bit values, each corresponding to a 4x4 pixel on the screen. And based on the 2-bit value, it assigns a color to that 4x4 square. 0, 0 is the background color, 0, 1 is the player 1 color, 1, 0 is the player 2 color, and 1, 1 is reserved for displaying menu screens. And then it outputs that color to the screen on the 4x4 square.
So in our current implementation, the current state is particularly buggy with the VGA. It is displaying multiple lines for a single player. So we still need to fix that. You can see a current working version of our Tron game on the right. Player 1 is the red lines. Player 2 is the green lines. And this is the current state it is in that we intend to make better.
You should show your screen and do a live demonstration too.
I can't. That is connected to another monitor.
Oh, never mind.
So thank you. This is our presentation for our project.